Thank you, Dr. Rafai and Dr. El Nashai. Thank you so much to the University of Houston for sponsoring and presenting today's summit. And we're really excited to go ahead and jump in right now to our program. We're going to start with our first theme, prediction, warning, and response to alerts and warnings. Our moderator for this session is Kishor Mehta from Texas Tech University. He is the P.W. Horn Professor of Civil, Environmental, and Construction Engineering at Texas Tech University. He's a TAMEST member from the National Academy of Engineering and is co-chairing the program committee for this summit and part 2 of the summit, which, as we mentioned, will take place in Lubbock next year. And with that, we'll turn it over to you, Dr. Mehta. Thank you.
Thank you, Terrence. Good morning, everybody, and welcome to the summit. I'm already introduced, so what I'm going to do is our theme 1 is going to have a plenary speaker. After plenary speaker, we're going to have a question and answer time, and then we're going to have a panel session with the 4 panelists, and I will introduce each one as we go along. Before I turn it over to Michael Coyne, who's going to be our plenary speaker on advances in hurricane and weather forecasting, I want to remind you of 2 things. One, that if you have a question, please put them in the Q&A, and at the time of the question and answer period, that I will be able to pick that up. The second one is please keep yourself mute so that we can continue with the program. So without taking any more time, I'm going to turn it over to Michael Coyne for his plenary speech.
All right, thanks, Dr. Mehta, and thank you to the group. Thank you, TAMEST, for inviting me to come speak to everybody. Sorry that we can't all be here together, at least we're doing it virtually. Look forward to maybe being able to do this in person in Lubbock. So I'll also say thank you to the University of Houston for sponsoring this and running this. It's been one of the smoothest transitions in for a virtual conference that I've been a part of over the last couple of years. So thank you for that. So I am the the regional director at Southern Region for the Weather Service. We're located in Fort Worth, Texas. I'll talk a little bit about hurricane and weather forecasting, some of the advances we're making, and where we're seeing some of the gaps, at least on the operational meteorology side. So if we go to the next slide, I will talk a little bit about the Weather Service for those that aren't familiar. The Southern Region covers pretty much the southeastern portions of the U.S. We also take in Puerto Rico and the Virgin Islands. So you can imagine we are very busy during tropical season. That tends to be the time when we get activated most often. But of course, we also have a very active severe weather season, flooding across mainly the hill country, then going into the Tennessee Valley. And then we also have fire weather and winter concerns across New Mexico. So it's a very active region. The state of Texas is covered by 13 weather forecast offices that have responsibility. Not all of those are located in Texas, for instance, Shreveport or Lake Charles or Norman, Oklahoma, but they do have counties in Texas. There's also 2 river forecast centers that have responsibility in Texas, although the largest by far is the River Forecast Center in the Fort Worth office. And then we also have Center Weather Service units. They are aviation units that help FAA manage air traffic control in terms of avoiding weather, anticipating things so they can minimize delays and keep air traffic flowing. So it's a pretty complicated system that we have. If we go to the next slide. So I'm going to talk mainly about hurricane forecasting and warnings, at least from the Weather Service side. I'm going to get in a little bit of the details of what we do. So when we get into a hurricane operation, it's a 6-hour repeating process. We do have observations that are fed into the national models. As we normally launch weather balloons at selected locations across the nation every 12 hours, but when we get into hurricane situations, if we feel like the models could benefit from additional upper air observations, we'll launch those every 6 hours. We take those, we feed them into doing forecasts, and we produce well over 50 different forecast scenarios that come out for each hurricane scenario. And then there's a long period of collaboration and coordination that goes on between the National Hurricane Center, which is in Miami, our Regional Operations Center, which is in Fort Worth, and then our local offices that are going to be impacted by these storms. So there's a lot of information, push and pull that goes on there to come up with a one coordinated message. And I'll talk about why that's important as we get further in these slides. The National Hurricane Center is the one who issues the official forecast. So you'll see the official forecast come out most of the time during the summer hours, 4 p.m. for instance. You'll see the forecast come out with positions and the forecast strength. The local offices, however, start to talk with the local public partners to talk about the impacts that are expected there. If there's, watches or warnings issued, what that actually means and what actions are recommended. And a lot of those recommended actions get into interplay with local officials. The Weather Service does not, for instance, sound sirens across outdoor sirens, for instance, with tornado warnings. With hurricanes, we do not issue evacuation warnings, but we do try to be honest brokers in providing the information to the decision makers, the emergency managers, the county judges in Texas, and let them provide the information to the public in an informed way. So that cadence goes on for every 6 hours until the storm moves on shore and dissipates. So let's go on to the next slide. So I'm going to hit some really good news points that are going on with hurricane forecasting right now. We are seeing the best forecasts that have ever been produced at this point in terms of tropical cyclone forecasting. And this graph here, this is from the National Hurricane Center. This is 96-hour error versus consistency. So how consistent is the forecast every 6 hours? And what is that error like every 6 hours? So the dots you'll see, the UK Met, the GFS, ECMWF, those are all weather models that are used. The GFS is an American model, UK, obviously UK. ECMWF is a European model. The NHC, that is their forecast. So they tend to be more consistent in their forecast. Models, one run to the next run, 6 hours later can bounce around a little bit. They jump around. There's not always the kind of consistency you would like to see. But having a human over the loop of that and understanding and interpreting that data, you tend to get a more consistent forecast. And combined with the experience, you get a much more accurate forecast over the course of time. So next slide. So this kind of shows how much improvement there has been. This is the that yellow dot. If that was a forecast point for a tropical cyclone in 1990, that blue circle is what the average error would look like at, I believe, at 72 hours. So if we hit the next slide, you'll see this is where we are today. So the differences have been amazing. Computing power, ensemble forecasting have really made a difference in how well we're able to forecast. So next slide. Another aspect of our forecasts that have been really beneficial to the public, we began storm surge modeling and storm surge warnings over the last couple of years. And so we produce a couple of different maps when we have the forecast produced by the National Hurricane Center. We take that track and the wind radii that are expected, and we produce a map of what the expected storm surge is and what the modeling is. This is from Hurricane Laura, so you can see the last year, so you can see the very high amounts that you have across southeastern Louisiana, but even going into Texas with the forecast scenario that we were running at the time. This has been extremely beneficial on helping people visualize the dangers that can occur with storm surge flooding. We'll talk about some of the gaps coming up. This is also, we're also, I would say, struggling a little bit with the fact that our forecasts are now so accurate that people take them to be absolutely accurate, and that's not always the case. So next slide. So working off Hurricane Harvey, I think we all remember that in Texas, how much rainfall fell. across Houston, southeastern U.S., and how large of an area was inundated with water. One of the outcomes of Hurricane Harvey was to really press on research for what's called inundation mapping. And here's a couple of examples of what's going on along the Guadalupe River currently. So this is only in certain channels in Texas. We're slowly growing this out. It's a multi-agency effort, also including academia, the National Water Center, which is in Tuscaloosa, Alabama. So it's a very large effort. It's a very difficult effort, but the results are so far really, really good. You can see with this flood map, the one on the right is probably the more pertinent one that shows water extent, maximum water extent with a forecast. So when the River Forecast Center in Fort Worth issues a forecast and issues their warnings, before this yellow dot or the red dot, I'm sorry, that's in here in the screen on the second image, that is where the forecast point is for that river. So before, you'd only get a forecast point and say the river's going to rise to 27 feet, whatever the number is. And so users would have to try to understand what that actually meant. With this flood inundation mapping, it's now given us the possibility of showing this is the extent, maximum extent possible of flooding. So decision makers can now move resources into the area properly, move things out of the way when needed. So this is a really, really promising area of forecasting. And I believe this is something that may be talked about down the line on a further talk today with Dr. Mehta, who's had a lot of work with the National Water Model and some of that work. So next slide. And good news also, intensity forecasting has been problematic over many years when you do hurricane forecasting. However, we are really getting pretty good at identifying when rapid intensification occur. That's when we see very quick strengthening of storms. In fact, in Hurricane Ida, which impacted the New Orleans area, the Weather Service issued for the first time the largest rapid intensification forecast ever. And while it did identify the rapid intensification, we actually undershot it by about 10 miles an hour. So we are doing much better in this area. Intensity is a very difficult thing to forecast with tropical systems. And we are getting much better at recognizing it and anticipating it. So next slide. So on every measure I've been talking about here, we're doing better. So why are people still perishing in these storms? Why are we sitting back and watching news reports and you see people that are making obviously bad decisions and you're wondering why are they doing that? So I'm going to break into a little bit of what we believe we're seeing and what we think some of those reasons might be. So next slide. So I would term them into two different areas: forecast interpretation and societal actions. And I'll get into each of those. So let's go to the next slide on that one. So societal reactions. One thing to remember when we see people and you're wondering what are they doing, we do have work with social scientists, and one thing to always remember: people make rational decisions with the information they have at hand. It's not always the decisions we would make, but no one's making irrational decisions. We have also recognized over the course of time that people don't always take the right actions when there's not a level of trust. We first started to recognize this even in the early 2000s. The Weather Service an office would issue a tornado warning, and you find out as you're doing the survey, the first thing some people did would be to go out and look out their window, or go to the TV and turn it on, or call a friend and find out what's happening. If they don't understand the source or trust the source, people are going to try to validate that information in the best way possible. And we don't. And as scientists, we don't always have control over a situation like that. Another thing to remember especially during hurricane situations, a large segment of society just cannot evacuate. We would love it if everybody could remove themselves from the area. It's the safest way possible. However, They have a job, they cannot leave. They have an elderly person they're caring for at home. They have pets and they have no way to care for those pets or take them with them. There are a lot of different reasons why people do not evacuate. But we find by and large through our studies after the fact with storms, everybody recognizes bad storms coming. They're putting themselves in danger. They just feel at the time they're making that rational decision that they cannot leave for whatever reasons that are tying them to the local area. So go ahead. All right. So our next challenge, talking about understanding forecast information, even very robust users of the Weather Service information and products can still apply the forecast in the wrong manner. We also have a problem in, these are two separate thoughts here. We also have the challenge of sometimes information is not coordinated in a way where people feel like they get a second forecast or they get conflicting information. And I'll steal from a football cliche. If you have two forecasts, you have no forecast. In football, it's if you have two quarterbacks, you have no quarterback. What we have found is if there is not a strong coordinated message across all levels of our agency, and also including partners as much as possible, people will be confused if they hear they should remove themselves from an area, and then someone else says, no, you don't have to. Or if they hear the winds are going to be 120 miles an hour, and then someone else says, no, that's going to be west of your area, you're going to have winds of 100 miles an hour. Little changes in information like that can cause confusion, and it results in inaction by the person. So next slide. So the storm surge modeling that I was just talking about that is so great, it also has led us to having to go through some strong education efforts because the information sometimes is taken verbatim and not clearly understood. We did see this with Hurricane Laura. So I don't think my mouse can be shown on this part, but if you look at the blue dashed line, oh, there we go, sorry about that. Do the blue dashed line, that is the hurricane forecast that was made. And then the purple line is the actual path of Laura, an extremely accurate forecast in terms of what we would consider in meteorology. However, if you look at those shades, that's the difference in storm surge from what was forecast with that original blue line and what was observed off the purple line. For instance, the Lake Charles office in our area, we had to evacuate that office because there's a threat of storm surge, and under the original forecast, it would have been put in 7 feet of water, which is a very dangerous situation for everybody there. However, the hurricane shifted to the right slightly, so they did not get the storm surge. However, they took a direct impact, and we lost our radar, as some of you may have seen last year. So next slide. Talking about people maybe not understanding information. So I will tell a quick story on a Hurricane Ida. We're still going through our after action assessments and service assessments. But one thing we did hear from a very strong partner of ours was they didn't think it would be this bad. And after doing some investigation, what we found was they did not anticipate a hurricane may wobble slightly off path, which is a normal thing. And they knew that through training that we had given the person. However, personalizing that information and understanding it was a little different, and they were not expecting the strong eyewall winds to go over portions of the person's area. And so they were caught off guard, although they were expecting winds of 100 knots. They were not expecting the 120 knot winds, which caused much more damage. So next slide. With rapid intensifications that we've been seeing, 2020 was just a landmark in this. We saw 9 different storms go under rapid intensification. Ida went through a rapid intensification. As we talk about climate change, we get the question, is this tied in? Only time will tell as we get, 10 or 20 years of this kind of data. But it's certainly disconcerting when you see rapid intensifications on this scale happen so frequently. And, we're still working as meteorologists to understand that. But the long and short of it is people may make decisions off a storm that is only a tropical storm and is much stronger. So let's go to the next slide. And so to highlight that, we've had 5 hurricane landfalls that were Category 5 in the United States in recorded history. All of them were tropical storms or depressions 72 hours before landfall. So the timeline to evacuate is also shortened with rapid intensification. Or worse, the message is not heeded. The person sees something on Wednesday, they think the storm's not going to be bad, and all of a sudden you have a major hurricane making landfall, and they have not been paying attention because they've dismissed the information since the beginning. So next slide. I will touch on this briefly. I think this is also a gap. This is something we're starting to get into with societal understanding. Social scientists are talking with us. The Weather Service has always been deterministic in their forecasting. Over the last 10 years, we've really started to go into probabilistic forecasting a little bit more, but we're just dipping toes in. This is going to take a lot more work of understanding not only what the forecast is, but also how people interpret that forecast. We are seeing some promising areas by using a 10% chance of exceedance kind of map. That helps decision makers maybe understand where there's at least this strong chance that things, if we're off a little bit, where we may be off. So this is, again, much more research is needed because you want to have the right actions made out of the forecast that you give. So next slide. So some final thoughts. Obviously, we're going to continue as an agency to improve our warnings and forecasts, try to make them as accurate as possible. But we are recognizing now that having our partners and users understand the forecast, having the public understand that forecast is becoming a greater challenge. And we really need social science to help us bridge the gap on maybe messaging and placing a greater emphasis on our field of study. So I believe that's all I have. And I will hopefully left us plenty of time for any questions.
I need to get off the mute. Very good, Mr. Coyne. I was trying to get my video on, but it works. Okay. Well, the couple of questions that came up, and we have some time limited though, is what do you see the biggest threat to hurricane and weather forecasting? How can we, is there additional need to improvement?
Well, being a perfectionist, I'd always say there's always need for improvement. I think intensity forecasting is probably the last nail that we really, have some improvements to make where we could see, just improving the numbers will improve, the response. I think where we are location, in our location of forecasting is very good right now. I do worry that we are getting so accurate that it implies that that line is going to be the line. We try to tell people, look at the cone of uncertainty on the forecast. Don't concentrate on the line. But it's a very human response to concentrate on that line. And so little variations, a wobble of a hurricane by 10, 15 miles, which is just really in the noise level, can make huge differences county to county if it's making landfall in Texas. Imagine a landfall in Freeport as opposed to Galveston. And that would be a very small error overall, but the impacts would be incredible.
Yeah, so one of the questions, even in my mind, you made a very good point that National Hurricane Center forecast is the most dependable. At the same time, when we see TV 48 hours before that, we see spaghetti. There are several different ones coming. So how can we change that concept that it's not confusing to people that which model is going to be good. Do you have any thoughts on that?
Yes, I think it's a huge challenge. From a local level, our offices spend an inordinate amount of time working and building relationships with the local TV partners to try to have everybody on the same page. That certainly is not successful 100% of the time, of course. I think when you have everybody loves posting the spaghetti plots, and I think one of the things we've done, at least on the social media side, is try to caution people to not necessarily focus on any one path, but always look at the cone that goes along with our forecast, that cone of uncertainty, which most of the time all those spaghetti plots take into account. But it is very difficult. I could pontificate a little bit further. We see what misinformation on Twitter and stuff can do in the medical field, and we're not immune to it in the meteorological field. And so not only do we have problems with what a spaghetti plot is, but we also have the problem with a person that is, we jokingly say, sitting in their mom's basement, and they make their own forecast. And we do have significant issues that arise from fighting misinformation like that.
David Daniel has a question, is how do you approach communicating reasons for uncertainty in prediction and how it can be improved?
Well, what we do is one thing we do is we do acknowledge with decision makers where there is a lot of uncertainty. Certainly we're getting better in hurricane forecasting, but there are certainly weather scenarios out there where we do see very difficult forecasts, and we will communicate that this is a low confidence forecast, or this is a high confidence forecast. And we will also take the step further, saying sometimes if we understand what the worst case scenario is, this could be the worst case scenario. If we're wrong, this is where the error is going to lie. So we try to not only give an idea of how confident we are in our forecast, but when we don't have that confidence, where we think we may have an error going on, and that does help with the decision making.
Okay. Got one last question. You made a very good point that the improvement in forecast has been excellent over the last 20 years, and there is a place where we're going to be able to improve, but it's going to take time. But so how can we convince the people to take action? So is there a way of telling them the consequences of it? In other words, you're going to have trouble with the infrastructure, electricity, you're going to have problem with the waters and so on. Is that a way to go? Have you run into that situation?
We have, and we think that we've made some progress through social science in our messaging. One of the things that we have done is when we see a very severe event, we'll use Ida, for instance. If we think the storm surge would be an unsurvivable event, we'll say unsurvivable event. And that certainly gets people's attention. We also talk about some of the things you have mentioned about what the conditions will be like in the days or even weeks after an event. And sometimes that helps people realize that maybe riding out the storm is okay. The house may survive, but can they survive without power for 2 weeks? And so that has also helped. So you're right. And trying to not only tell them the forecast, but also the expected impacts has been a benefit.
Okay, very good. Well, we're running out of time, and so trying to stay on time, I would suggest to the audience that if you still have questions, is to send it to you with your email address. Is that Michael Coyne at NOAA.gov?
It's mike.coyne@noaa.gov.
Mike Coyne. Okay. But when I say wrong, that means it stays in their mind better.
Yes. There is. I was going to say, there's strangely enough, there is another Michael Coyne in NOAA. He's with the National Ocean Service, so he'll forward the email to me if somebody does send it the wrong one.
Yeah, Very good. Well, we're going to move into the panel since the time is limited.